And so I am going to stop my share and introduce our guests. And we have with us, coming from Flagstaff, Arizona, one of the magical things about these speaker series is that we can bring in people from anywhere. We've had people from Athens, Greece, and now today even Flagstaff, Arizona. So we're great to welcome Bill Sheehan, astronomy historian. He has been an amateur astronomer most of his life, and he's a leading historian of astronomy with 20 books to his name, including Planets and Perception, Worlds in the Sky, The Planet Mars, and Discovering Pluto, all published by University of Arizona Press. He's a current member of the International Astronomical Union's Working Group of Planetary System Nomenclature. He has received a Guggenheim Fellowship for Astronomy Writing and is a recipient of the Gold Medal of the Oriental Astronomy Association. The main belt asteroid 16037 Sheehan was named in his honor, and he's here today presenting as co-author of the latest U of A publication, Discovering Mars, A History of Observation and Exploration of the Red Planet. So thank you so much today, Bill, and I'll let you share your screen and take it away.
All right, there's the screen. All right. Well, I wish I could be there in person, but I'm up here in Flagstaff, probably about 20 degrees or 30 degrees cooler up here than it is in Tucson. But the subject that I'm going to talk about today is one of universal interest, the planet Mars. And if you were to go outside tonight and look around for a bright orange star in the sky, Mars, you, unless you've been paying a lot of attention, would probably not be very successful, because Mars right now is almost on the other side of the sun. It would appear as a very dim yellowish ember shortly before sunrise. And the various spacecraft that are now on Mars are just reclaiming communication with the planet. But if you had looked a year ago around Halloween, you would have seen a brilliant star, one of the brightest in the sky, and the most intensely red object in the sky, looking very much like it did to Walt Whitman in 1879. Walt Whitman, the great poet, said, "Coming back to St. Louis this evening at sundown, and for over an hour afterward, we followed the Mississippi close by its western bank, giving me an ampler view of the river. In the eastern sky hung the planet Mars, just up and of a very clear and vivid yellow. It was a soothing and pensive hour, the spread of the river off there in the half light, the glints of the downbound steamboats plodding along, and that yellow orb apparently twice as large and significant as usual above the Illinois shore. All along these nights, nothing can exceed the calm, fierce, golden, glistening domination of Mars over all the stars in the sky." Leave it to a poet to be able to say things well. Well, in 2018, Mars came to one of its really close approaches to the Earth, and I'll explain a little bit why Mars varies so much in brightness over time. But one of the things about its motion that has bewildered people from prehistoric times is that though it usually follows a kind of a direct movement in the sky from the east to the west, around the time that it's opposite to the sun and brightest, it makes a zigzag or loop-the-loop kind of a motion as shown here. So as you can see over that summer into the fall, it made this very strange loop in the sky. And that was a source of considerable perplexity to early people. The ancient Greek astronomer Ptolemy and his contemporaries mostly figured out a very complicated scheme to explain this backwards motion. And at the time, everyone believed that the Earth was a solid central object in the universe, and that all the planets and stars were sort of on the fiery sphere that sort of revolved lightly around the Earth. And so he came up with this kind of circle on circle movement, which did a pretty good job of explaining what we saw, but it didn't do a very good job of satisfying someone's aesthetic desire to have the universe operate on as simple as basis as possible. And one of the themes that I'm going to be stressing today is that Mars has always been a master illusionist. It's actually had several compelling illusions that have bewildered humans over time. And only now, I think, in the current era that we're living in, are we starting to see Mars as it really is divested of illusion. But the first illusion was discovered by Copernicus. And what he realized is that if the Earth and Mars are both moving around the sun, that essentially what we're seeing are perspective views of Mars as the Earth catches up and then passes it, which produces this illusory loop-the-loop motion. Both planets continue to move in the same direction, but Earth is moving faster and it overtakes Mars. It creates this illusory retrograde motion. And so that was one of the great achievements of the Copernican theory, the heliocentric theory, is that it could explain this motion basically by a couple circumscribed circles rather than this complicated loop-the-loop epicycle scheme that Ptolemy had used. Building on Copernicus's work, Tycho Brahe and his assistant, Johannes Kepler, were able to show that the actual shape of Mars's orbit was not a circle, but it was instead an ellipse. And that brings us to our next point. This is a nice statue of them, by the way, in Prague, which is where they both joined up to do some of their work together. So the Earth is this orbit, and you can see what the orbit of Mars would be if it were circular. Well, in fact, by being an elliptical orbit, Mars sometimes kind of crosses inside of that circle, and at other times it goes outside. And Earth's orbit is also elliptical, but to a much lesser degree. So depending on where the Earth encounters Mars in their mutual orbits, the distance between Mars and the Earth can be very small relatively. So in October of 2020, it was about 40 million miles. And at other times, as we're going into now in these later 2020 era approaches of the two planets, it can be as much as 63 million miles. So there's quite a variation in terms of how well Mars is seen. And another thing that can't be seen on this diagram because it's not three-dimensional is that sometimes Mars is far to the north, which happens to be the case with these bad oppositions, as they're called, because Mars is opposite of the sun. And it tends to be quite far south at the favorable opposition. So that gives observers in the southern hemisphere a distinct advantage over northern observers in terms of seeing Mars when it's closest to the Earth. Now, as I mentioned, Mars has this peculiar motion, and it also has a reddish color. And those are the two things that really stood out to ancient astronomers. One, that it had these kind of maniacal movements across the sky where it was doing these strange backwards kind of pirouettes. And the other is that Mars is one of the few really red objects that we see in the sky. If you go out and look at the sky at night, you'll see very few vivid colors. And Mars and a couple other stars, Antares, Betelgeuse, are a couple reddish stars, but red objects are really quite striking, partly because of their rarity, But the other reason is that red has a really strong effect on our nervous systems, the way we react to it. And what I'm trying to do here is just to show some of the backgrounds, even in basic physiology, as to why Mars, of all objects in the sky, has had such a compelling hold on human beings. So why is red a specifically important color to us? Well, it has two meanings. It can be both a sign of danger, as with these African tree frogs that are poisonous. So the red color alerts us that this is something we better kind of not approach too quickly or too near. But it also is an attractant. Red flowers are notorious for symbolizing desire. Restaurants use red coloring. Red light districts are notorious as being this is a color that really increases our desire for various things. And so we really pay attention to red because we have to really be careful to find out which of the two modes of reddishness are being suggested to us. We want to make sure that we get the right signal. We don't want to attract something that's be attracted to something that's poisonous. And on the other hand, we don't want to stay away from things that may be more appealing. So there's an old saying, red skies in the morning, sailors warning, red skies at night, sailors delight. And that captures that bimodal aspect of red. And if you want to really delve into this sort of thing, everyone knows about Cortez and the conquistadors and their thirst for gold. But what was equally valuable was the dye from these cochineal insects, which are found in Mexico, the source of carmine. And they completely revolutionized Renaissance painting, because for the first time, these vivid reds became available for artists. There are artists like this Mark Rothko who have only painted their canvases in red. So all of these are tributes to the way that red affects us. And of course, blood is red, and for the same reason that Mars is red. Blood is red because of hemoglobin, which is an iron-based moiety in the red blood cells. And for the same reason, Mars is red because of rust, which is iron that is basically combined with oxygen in the same way that oxygen and hemoglobin combine. And so early on, because of the connection with blood, Mars was seen by many civilizations as a war god, as in this depiction of the war god Mars from Pompeii, a fresco there. So anyway, Mars had started to stimulate our interest just because of its color and its movements long before anyone was able to really do a scientific study using a telescope. The first view of Mars that actually showed any detail, because Mars is both small and usually quite far away, was Christian Huygens. And in 1659, he used a telescope. This rather unwieldy type of contraption was what they had to use back then, because the glass that they had was not a very good quality, and so it tended to create a lot of out of focus coloring that obscured detail. But anyway, he made out Mars probably looking about like it does in that little picture, and made out these darkish areas on the disk. This was later called the Hourglass Sea, and it's now called Syrtis Major. But that was the first time that anyone had actually seen anything of the surface of Mars, which even though it's twice the size of the moon, is always at least 140 times further away. So it's really hard to study. Well, as telescopes got better, we were able to see more clearly what was on Mars. Here's a map that was done in the 19th century by a famous British geologist named John Phillips. He was at Oxford. He was the first person that actually attempted to do a geological study of Mars to try to find out a little bit about what the nature of the markings on Mars which by then had been established to be stable and permanent, might be. And he thought these reddish areas might be related to the old red sandstone, one of the well-known strata in England. But these other areas, which appeared to him as greenish in color, he thought were probably seas or possibly areas of vegetation. And these, obviously, these reddish areas were lands. Well, this is actually a fairly good representation of the colors of Mars as seen through a telescope. And again, Mars is a master illusionist. And already in Phillips's time, people began to wonder, well, are these really the true colors of Mars, or are we being deceived just because of the way our eyes work? Well, it turns out, at least in part, we were being deceived. And this is an interesting story in and of itself. One of the things about perception is that we don't see anything in terms of absolute levels. We don't see absolute levels of light or darkness. We don't see colors in any absolute sense, but only in relation to other shades or colors that are in proximity. So it's important to realize that the color that we perceive is due to contrast with other colors. And this was first studied by a chemist named Chevreul, who was employed by the French dye industry, and to try to understand why some of the colors in tapestries looked so faded and unimpressive. And what he discovered was that actually what we see when we look at threads in a tapestry are not the threads as they would look to us if they were just set apart in isolation, but relative to other threads that are next to them. And so by combining these different areas of thread in a tapestry, you can bring out really vivid colors that otherwise would look drab and unimpressive. And some of these discoveries were later used by Impressionist artists. And he was the first person that defined the color wheel and the complementary colors, which we know are quite familiar with today. Well, all of this relates to Mars because, as I'm going to show you, what we see is really dependent upon these contrasts. So right now, what I've done is shown you a picture that has a swath of gray in the center, surrounded by a white background. Now, the same swath of gray is going to be shown to you with different backgrounds, and I want you to sort of see whether you think that swath has the same color as it moves from one slide to the next. Against a black background, that looks quite a bit brighter, doesn't it? And by the same token, when we look at the moon at night, it looks blazingly white, like ivory. And yet, if you look at the moon during the daytime above a parking lot, you'll find that actually it's about the same color as the asphalt on a parking lot. So again, if you see something at night, if you look at a planet in a telescope, you're going to see it very differently. Now there's a swath, again, the same swatch of gray that I showed you before, but now against this kind of reddish background like that, which is seen on Mars. And now it looks a little bit bluish, perhaps, compared to this one. So we were, and this is even closer to the view that one has in a telescope, where I've surrounded this sort of squarish Mars, schematized Mars, with the black background that you would see in an aperture view in a telescope. And so you can play around with these different kinds of colors. Some of the old spaghetti westerns, for instance, were color, but they only used two different colors in reality, and the eye and the brain did the rest to fill in the gaps. So the question really became one of what colors really are Mars? And this also raises the question of what the eye sees depends a lot on the seer. In 1877, which was a really favorable position of Mars, when Mars came close to the Earth, it was studied intensively by astronomers for really probably the first time in history. For instance, in Washington, D.C., using the U.S. Naval Observatory telescope, Asaph Hall discovered 2 tiny moons of Mars, which was an important discovery. This fellow, Nathaniel Green, who was a portrait artist, landscape artist, who gave actually lessons in drawings to none other than Queen Victoria, went to the island of Madeira with his telescope to sketch Mars. And here are some of the examples of his work. And so he really showed Mars as you would expect a portrait or landscape artist to do so. It's kind of romantic, dreamy. The various markings are shown in a kind of a very subdued, nuanced way. And at the same opposition, this gentleman, Giovanni Schiaparelli, who was at the Brera Observatory in Milan, observed Mars. Now, Schiaparelli was a very eminent astronomer. He had been trained in the use of a micrometer, which is an instrument that is used to measure very tiny angles in a telescope. And he also had been trained in surveying, the kind of draftsmanship that like an architect or a civil engineer would use, which was in fact part of his training. And he observed Mars with a very different purpose from the one that Nathaniel Green, the artist, had done. What he wanted to do was to get precise measurements of clearly defined points on the planet and make a map that was very accurate. Also he was interested in coming up with a kind of a consistent set of names that could be used for Mars. So here are a couple of his drawings of Mars, very different from those of Nathaniel Green. And here are their 2 maps. The one up above is Schiaparelli's map. Everything is measured very precisely. And here is Green's map. They're very different, and this illustrates really what's called the personal equation. We really see things very differently depending on our point of view, but it's very difficult to tease that out because, of course, we tend to always see things from our point of view. And as a result, it wasn't until the early 19th century that something as straightforward as color blindness was recognized, because everybody assumed up to that point that whatever they saw as red or blue or green was the same thing that everybody else saw. So with Mars, this was really very apparent. Schiaparelli's map also was different from Green's in that he showed these streaky markings that sort of looked like rivers to him at first, and they sort of were connected together, and then with these larger expanses, which he thought were seas. And so Mars appeared to be maybe a little bit like the Earth from the standpoint that it had oceans and bays and rivers, but most of Mars was more of these kind of reddish continental areas, as they were thought to be. So that introduced a new way of looking at Mars. Now, Schiaparelli in his nomenclature really suggested that the names should be chosen only for convenience, to help scientists talk to one another about what they were seeing. And he didn't necessarily mean that they should be taken seriously. And he pointed out, for instance, that on the moon, the term seas for dark areas wasn't believed by anybody to suggest that they were areas of water. And so we named these. Here's Mare Austral, the southern sea, and various bays. This is Mare Erythraeum, the Red Sea, and so on. But his names were drawn because he was Italian, very well versed in the classics, from the mythology of ancient Greece and from the Bible. And so these names, innocuous as they may have been when they were suggested, did create this sort of romantic, nostalgic aura around Mars. And no term was more misleading, perhaps, or perhaps seminal and instructive to later observers than the one that he gave to these grooved areas. He called them canali, which in Italian means channel, it means grooves, and it can mean canals, but in English it was pretty much translated universally as canals and was interpreted as being canals in the artifactual sense. And that brings us to Percival Lowell. I couldn't resist putting that this painting from the Boston Public Library, which shows the visions of Sir Percival from the medieval legends, his search for the Holy Grail. And Percival Lowell's quest was for the Holy Grail of life on Mars. And he came to Flagstaff and spent a lot of his time here. He's somewhat of our own. Well, Lowell came from a very prominent New England family. In fact, the Lowells were the most successful capitalist family of New England in the 19th century, and they made their fortunes from textiles. They operated huge textile factories in Lowell, Massachusetts, and in Lawrence, Massachusetts, where they harnessed rivers to be able to drive the big water wheels and engines that were needed to run these looms. And they hired these, what they call bobbin girls, basically farm girls who, before they got married and settled down, would spend a few years working in the rather unsalubrious conditions of these big factories, and turned out these cotton fabrics. And of course, this was the mid-19th century. All of the Lowells were what were called cotton wigs. In other words, they were unlike conscience wigs who believed that slavery was wrong and wanted to abolish it. And the Lowells were quite happy with slavery as an institution because it was the cotton that was grown in the southern slave states that fed their mills. They made a fabulous amount of money. They were philanthropic. They gave their fortune to lots of good causes in Boston. Basically, they created the fortune that Percival Lowell, who was the eldest son from the most successful branch of the various extended Lowell families, as much money as he needed to do pretty much whatever he wanted. I graduated from Harvard in 1876. He was called by his math professor the best mathematician of any that had come under his observation. His second cousin, James Russell Lowell, a poet, said he was the most brilliant man in Boston. And Lowell, as the eldest scion of this successful family, was expected to do as other Lowells had done, and basically, after he graduated from Harvard, become a businessman and expand the family fortune even more by basically being the chairman of various trusts, including trusts for not only the cotton mills, but railroads, other industrial interests of the time. And Lowell was well on his way to following that career path. He was actually engaged to none other than Teddy Roosevelt, an upcoming assemblyman from New York, his sister-in-law. And then suddenly Lowell just seemed to collapse in terms of his ability to follow through with that whole prescribed route. He broke off the engagement. He dropped out of the business, which greatly angered his father, and decided to leave it all behind and do something more adventurous. So first he spent about 10 years in the Far East, and here he is in Korea and in Japan, where he spent a great deal of time studying the culture there. He was aware of the fact that Japan was rapidly modernizing, industrializing, and that it was a last chance to see the way it was before all of the Western changes took place. who wrote 4 books on that, became quite well known for his Japan writings in particular. But finally he got kind of tired of that. And maybe he was a little bit manic depressive, because at the end of his last trip to Japan, when he returned from Tokyo, he seemed to have a different bee in his bonnet. He read a book that was written by a famous French astronomer, Camille Flammarion, about Mars, and it utterly captivated his imagination. And being a Lowell and having connections, he quickly managed to scramble together to put a team of experts at his behest. William Pickering was a professor at Harvard, very interested in Mars. He had gone to South America and observed Mars under really good conditions in 1892 from the footholds of the stratovolcano El Misti. And Andrew Ellicott Douglas, who was Pickering's assistant there. And Pickering had said to Lowell, well, the best thing to do if you're interested in studying Mars is to put a telescope in the best atmospheric conditions you can for studying the planets through a telescope. He had found those in South America, but he said the same good conditions were likely to be found in what was then the Arizona Territory. This was 1894 when all of this was going on. So Lowell had brought this telescope that's shown in this picture with Douglas with his pith helmet, along with him to Japan, and sent Douglas out to Arizona. And Douglas prospected several sites. It wasn't a very scientific study, because Douglas only spent a few days in each place to try to see whether the air was steady enough to see the stars well. And one of he started out in southern Arizona. And some of the places that he looked at may look familiar. If you don't recognize that, there it is today, which I think that is at the University of Arizona campus or Arizona State. Anyway, one of those campuses. He did start out in Tucson.
Yeah.
He went to
You
Tempe.
have to be careful. Those are fighting words there. That's ASU.
Is that ASU?
Yeah.
Yeah, pardon my ignorance. I had wanted to put one up of the University of Arizona. Somebody, this is kind of Maxwell's demon or something that swapped them out for me. Anyway, he started out in southern Arizona, and actually that's where we now know the best seeing conditions for astronomy exist, especially around Tucson. But he didn't encounter good seeing down there because he was only there for a few days, and eventually he worked his way up to Flagstaff, and he was here for a few days. The seeing was good enough, but again, it wasn't very scientific, because you can't really tell what conditions are like if you only, it's like the old saying, what, who are they that know of England that only England knows? Or you can't judge a spring by a few swallows. But anyway, he did settle on this site because Lowell liked the height and the fact that it was on a railroad line. And also, according to Douglas, in his later years, his Flagstaff had the best saloons at the time. And this is what the site looked like when Douglas first visited it. And this is sort of where they chose to set up what Lowell sometimes was said to be doing, which was having an astronomical picnic with Pickering and Douglas in tow. This prefab dome was sent out from Boston to Pickering's design. Pickering borrowed 2 telescopes. This one, which is larger, the Brashear telescope, which is actually intended for Philadelphia's Flower Observatory, but before it was set up there, they detoured it out to Arizona, and this Clark telescope, which still is at Lowell Observatory. And so with these borrowed telescopes, they set to work. And one of the things that people don't totally understand about the Lowell expedition was that Lowell was completely inexperienced as an astronomer. He'd done a little bit of hobby observing, for instance, with the telescope that he took with him to Japan. But he really had not done any serious observing. He wasn't a very good draftsman. He was sort of an awkward artist, but he had a lot of confidence, and it was very literary in his approach. So he already had a pretty clear idea of what it was that he was going to find even before he left for Flagstaff. In fact, a few days before, he gave a lecture in Boston where he basically laid out in prospectus all of the things that he eventually would find out about Mars once he came out here. And what he was particularly interested in were these linear markings that Schiaparelli had discovered, these canals. And what's interesting about them is they just appeared in flashes. They were not something that you could just sort of like watch steadily and be really certain of. They just came up in flashes, and that, as you're going to find out in a few moments, was a key aspect to what they really were. So Lowell made these observations, saw all of these canals, and what he said was basically, okay, these areas that are kind of greenish in color or bluish in color that everyone thought were seas, they changed over the period that they were kept under observation. And there was this white polar cap at the southern pole that rapidly melted. And as it melted, these areas in here developed into sort of continuous bluish areas. And then as the season advanced and you got into early and late summer, they kind of dwindled. It looked like deserts were taking over. And then the canals came out. And what he said was these canals looked like they were designed by some intelligence because they were so straight and they followed such continuous courses. And everywhere they intersected, there were these little small spots, which Schiaparelli had called lakes, but he called them oases. The idea was that Mars was this desert planet, and that these various linear features were actually what they looked like, which was artificial irrigation canals. And that was what his map looked like from 1894. And it's an incredible map. I mean, it would be neat if Mars really looked this way. But again, all of these different canals were seen at different times, as you saw in the logbook drawing a few slides back. They didn't appear all at once. And so basically what this was a cumulative impression of all of these different apparitions, momentary apparitions that assembled, had this really striking form that really was suggestive that maybe there were some civilization that were building these things. And Lowell made little globes showing his observations. Well, we mentioned earlier that there's this thing called the personal equation. Not everybody sees things in the same way. And it turns out that at the same year, 1894, that Lowell was making these rather sensational observations, the most gifted planetary and best trained planetary astronomer of that era, Edward Emerson Barnard, who grew up in really impoverished conditions in Nashville, but sort of as a self-made man was able to become one of the most prominent astronomers of his time. He was using a larger telescope at the Lick Observatory, which is near San Jose. And we can now actually look at archival holdings and compare the drawings that these people made independently without awareness of what the other was doing at almost exactly the same moment. So here are Barnard's drawings, which were never published, and here are some drawings to roughly the same scale from Lowell's logbooks. And as you can see, they were definitely looking at the same aspect of the planet, but their impression as to what they were seeing was really strikingly different. And Lowell had a tendency to assert things in rather dogmatic form, and several of his dogmas included one, that Flagstaff had better air than any other place on Earth for viewing planets. Also that Mars, another dogma, that Mars was amazingly flat that maybe the highest elevation on Mars was a few thousand feet. There were no mountain ranges or canyons. And also that Mars essentially was a cloudless world, that it had a thin atmosphere, but clouds were rarer than hen's teeth, essentially, although he put it more eloquently than that. And Barnard, on the other hand, was seeing Mars with a much larger telescope under really superb conditions. And what Barnard noticed was that as he kept observing Mars, these features that seemed to remain the same over time, suddenly in another part of October, changed abruptly. And what he was actually seeing, he thought they were clouds. But this whole area here, where there's this line that Lowell shows just as a canal, this was actually the boundary of what we now know to have been a dust storm. And Barnard was able to see that. He was able to watch how the features faded out because of the, again, clouds, but which we now know to have been dispersed dust. And what is really striking is that the most characteristic feature of Mars, as we know it today, is that in contrast to the Earth, which is an aqueous planet, Mars is a planet of dust. And this was another aspect of Mars's master illusioning. We for a long time didn't realize that dust was sort of the coin of the realm on Mars. Well, another thing is that when you look at a planet through a telescope on Earth, of course, if you get above the Earth's atmosphere, it's different. What you're essentially seeing is a moving picture. The planet is continually fluctuating before your eye because its light is having traversed this boiling ocean of air. It's constantly in motion, and it's only sort of in momentary glimpses that one sees things really clear, and then the features sort of wash out again. You can, in really good conditions, like those at Mount Hamilton, where Barnard was observing, see really steady seeing for long periods of time. But in Flagstaff, they never really got that kind of seeing. And so Lowell tended to see these canals only in glimpses for maybe a fraction of a second. And that's one of the things I think that people have overlooked in trying to understand the various stages of our understanding of Mars. Namely, when you look at a map like the ones that I showed you earlier, including the one by Lowell with all the canals, people tend to think that the astronomers sketching those features were basically involved in an exercise in drawing still life. But the reality is that they were drawing a motion picture. And even though it's one of these kinds of standard cliches, that the eye is as fast as the eye, that the eye is able to see sort of at the speed of light kind of thing. In reality, the eye and the brain that it's hooked up to, and eyes without brains aren't really much good, unless you're an anatomist. The eye brain system is really pretty slow. And so in terms of like a digital camera image acquisition rate, it's about 8 images per second, which is really quite slow, as we now know, compared to some CCD imaging devices that can get 1,000 frames, for instance, a second. And that, in fact, is the reason why when we watch a movie, we don't see it as a staccato performance with individual frames being recognized. Instead, it appears to be a seamless, fluid motion. And one of the interesting sidelights to all of this is that until the invention of stop-action photography, there's a considerable debate among artists and people that attended horse races as to what horses actually did when they were galloping. And here's a painting from 1821, for instance, showing the way that horses were typically depicted sort of like they flew through the air, and then apparently must have landed on all fours before they jumped forward again. I've seen dogs do that, but never a horse. Well, it was stop action photography that finally solved that question. This is the man that was responsible for that, Edward Muybridge, and he actually collaborated with Leland Stanford, the founder of Stanford University, in winning a bet for Leland. Basically, Leland's position was that the horse basically had periods of time where it was actually flying in the air, whereas his antagonist said, no, that wasn't the case. All fours were off all the time or whatever. So anyway, this is the way the horse gallops. And so there really weren't any astronomers that saw Mars gallop properly until recent times. And here's a map that I did. It's actually a composite of 11 of Lowell's maps. He did one of these for every opposition. And so what you can see really here is that because again of the slowness of the eye-brain combination, what Lowell was actually doing was recording the saccadic movements of his eyes. He would see something kind of out of the corner of his eyes, and then he would try to move his eye to the position where he saw it, and then it would fade away. So he was essentially just recording a physiological aspect rather than anything that was intrinsic to Mars. Well, here are some Barnard drawings, and this shows what Barnard saw at Lick Observatory. In fact, this particular set of globes is having its world premiere right today, because I did these over the weekend specifically for this with some collaborators of mine. And as you can see, none of the canals, Barnard got a better look at Mars than Lowell did. And so he was able to see clearly what was there, and he didn't bother with all of these kind of evanescent, faint markings. And here's another artist, much more gifted than Lowell or Barnard. E.M. Antoniadi was Greek, and his drawings were amazingly accurate. This is one from 1909, and here's an image of Mars by Barnard at the same time. And as you can see, he's pretty much spot on as far as that goes. And here's a map of Mars by Barnard, and here is one by Mariner 7. So essentially the canals correspond to illusions, and Lowell's theories, although they were exciting and they stimulated a lot of interest, including my own, proved to have been will-o'-the-wisps. Well, Lowell thought that the canal builders were this benign, advanced, wise, peaceful folk that were staving off the effects of climate change on a geologic time scale. Mars was smaller than the Earth, lost its water and atmosphere faster, and the Martians had to resort to these vast irrigation works in order to stave off impending doom. And at the same time, another individual within a few years realized that there was an attraction in looking at the Martians as being perhaps a little bit more human than these peaceful, peace-loving folk. And that was H.G. Wells with The War of the Worlds. And H.G. Wells imagined the Martians escaping from their planet and coming to the Earth and trying to take over. And ironically, as most of you probably know from having read that book, what does the Martians in are not the Earth's military operations, which at that time consisted of cannons and things, but bacteria. The Martians didn't have resistance to bacteria, and so they were done in that way. Sort of a striking parallel, perhaps, to what we're dealing with in the current era of COVID. Well, after Lowell's time, there were various artists that attempted to imagine what Mars would be like before spacecraft arrived. Here's a not very well produced, because I got it off the internet, a depiction of one of the canals by Chesley Bonestell from the 40s. Lots of views of Mars like this. Another one of Bonestell's showing a desert planet. And Bonestell was a famous space artist, kind of a pioneer of that. And his paintings are worth substantial fortunes now, but was hired actually to do a panorama as a background for one of George Pal's sets, a movie that was supposed to depict an expedition to Mars. And the set that he did was rejected because it was basically told that it looked too much like Arizona. And the astronomer consultant on the movie basically said, well, that's because Mars does look like Arizona. Well, that certainly is something that remains to be seen. So I mentioned earlier that one of the things that confounded astronomers was that they failed to realize how dusty Mars was. It is a desert planet. And the dust that is dispersed during these big dust storms tends to remain dispersed all the time. So there's never a dust-free time on Mars. In fact, this brightening on the limb of Mars in some of these images is basically because dust is refracting sunlight and to create a kind of an intense twilight effect in those places. The other thing is that it led astronomers to overestimate how thick the atmosphere of Mars was. And the reality was what they thought was air was actually just suspended dust. So again, Mars has misled us in some awful ways. And here are some spacecraft images that show tails, which is basically dust that has been deflected around these obstacles, craters in this case, dunes, and all sorts of aeolian dust phenomena on Mars. And Mars has dust devils. They've been recorded from spacecraft, and it appears to be dust devil activity that sort of gets involved in positive feedback loops that lead to these gigantic dust storms in which the entire planet becomes obscured. And in fact, these images from 2018, I was really geared up to use the Flagstaff telescope that Lowell used to observe Mars because it was really close to the Earth at the time. But unfortunately, one of these dust storms developed. So by the time that I was accessing the telescope, it was essentially indistinguishable from a peach. Well, but I'm going to briefly segue into the Spacecraft Era. The book that I wrote with Jim Bell is about exploring Mars as well as discovering it. And we're now headlong into the modern era of exploration. We're really finding out what Mars is really like. And this is a somewhat nostalgic picture. The first time I ever had a chance to look at Mars through a small telescope, I was just 10 years old. I had one of those department store refractors that I set up on the sidewalk in front of the house and looked at Mars, which was much smaller than a pea, more like a pinhead. But beautiful reddish, and at the time, the books that I was able to access in the local branch library were several years out of date and still suggested that Lowell's ideas might be borne out. One of the TV series that was my favorite at the time, as you might guess from the little picture, was my favorite Martian with Ray Walston. And so it was sort of the last chance to really believe, even though hoping against hope, that Lowell's ideas of Martian canals and civilizations might be borne out by reality. Well, that same year that I observed Mars with the small telescope, the first spacecraft was launched towards Mars by NASA, Mariner 4. It had a twin that ended up crashing into the Atlantic Ocean, but Mariner 4 got underway successfully, and it was able to zoom across Mars and get a series of images, swatches of the surface were captured in these sort of bleak television images that were much worse than any kind of a Polaroid picture that you could have taken with a camera at the time. This was the first one. And as the images were fed back, the result was actually extremely depressing to someone like me who wanted to believe in the Martians. There were all of these large craters that were shown on Mars, and it appeared for a while that Mars might in fact be just another dreary world like the moon, lifeless, dead, crater-pocked, and that there really would be no point in investing in further spacecraft missions to Mars if all it was a moon that had been towed about 140 times farther away. Well, that kind of depressing view of Mars lasted through a couple more flyby Mariner flights. And then in 1971, the United States managed to send an orbiting spacecraft to Mars. Again, it was one of two spacecraft. The first one crashed into the Atlantic. The other one got underway, and this was called Mariner 9. It was a revolutionary mission, and I give it a particular billing this month, November of 2021, because 50 years ago in November, it entered orbit around Mars. And when it first reached orbit around Mars, it was joined by a couple Russian orbiting spacecraft. And the scene that greeted them was extremely hostile because Mars was again in one of these dust storms. And so the only thing that Mariner 9's camera was able to snap when it first entered orbit were the shadows of these, what we now know to be shield volcano calderas that were looming up above the pall of dust that was swarming over the planet at the time. The Russian spacecraft had been pre-programmed, so they weren't able to really see much of what was going on. But Mariner 9 had sufficient flexibility built into its program that it was able to wait things out and change the parameters of its mission. And what it revealed was a Mars that really was, for the first time, Mars as it really is. It revealed these gigantic shield volcanoes. This one was called Olympus Mons, 78,000 feet above the sort of reference level on Mars. Since Mars doesn't have oceans, they use sort of a mean diameter of the planet as the reference frame for elevations. So that tower is higher than Mount Everest on Earth, but it's much shallower. It's just basically a very gentle rise because it's a shield volcano. This gigantic system of canyons on Mars. This is much wider across than the Grand Canyon, and strange formations such as this one, which was called the Chandelier, clearly shows some serious compression types of fracturing, and then above all these kinds of features, which were initially thought and have since been shown indeed to be dry riverbeds, which showed that Mars earlier in its history must have had liquid water flowing on the surface, at least for periods of time. So suddenly Mars became a much more appealing subject of human investigation. Here are some other images from mostly the Viking mission. There's Olympus Mons again, this gigantic shield volcano. Some of the detail in the faces of these canyons, where you can see actually some of the subsidence of rock that has fallen down from the walls into the canyon. Here's the Martian dust storm getting underway. So this dust is being raised by essentially legions of dust devils and forming sort of a feedback loop until all of this dust will spread and cover the whole planet and warm it until it starts to fall off again. These are some intricate striations around one of the polar caps that show that, like with tree rings, you can actually show the different levels of deposition of water ice over time, and solid carbon dioxide. These dendritic formations of dry riverbeds, and these kind of windsock features, which basically were formed by winds. Here's what Mars looks like on the surface. The first images from landers, the Viking missions, and a lot of these images do evoke some of the impressions that observers such as Lowell got. He often compared the image in his telescope to the various colors in the painted desert, and Mars continues to be, let's say, the most Arizona-like planet that we've discovered so far. Well, the amount of activity that's gone on since those Mariner and Viking orbiters has been tremendous. Mars has become the grand central station of the solar system. And these are just a few of the orbiters that are currently still active around Mars, which include NASA's Mars Odyssey, which has been, that's the one up in the upper left, which has actually been successfully sending us data and images of Mars since 2001. So it holds a world record for any orbiting spacecraft around Mars of 20 years. There are also the European Space Agency's Mars Express, NASA's Mars Reconnaissance Orbiter, an Indian orbiter called Mangalyaan, NASA's MAVEN, ESA and Roscosmos, the Russian space agencies, ExoMars Trace Gas Orbiter. The United Arab Emirates has a orbiter around Mars. China has one. And the most recent one is, of course, the United States again. Actually, the United States doesn't have one of those recently, but it does have a rover. So this spectacular landing on the surface of Mars occurred last February. Many of you maybe remember the fact that they were able to get images showing the deployment of the parachute and the way the heat shield fell off and fell away. And then the rover actually landed via a sky crane onto the surface of the planet, which was a really innovative approach. This rover was called Perseverance, and the aim was for it to find evidence of possible water deposition, sedimentation, and even perhaps early organic life forms on near Jezero crater. And I'll show you in a moment the reason that crater was of interest. But the spacecraft was called Perseverance, and the nickname that's been adopted appropriately enough, perhaps, is Percy. That's what the rover looks like. And it's been moving around on the surface of Mars. And this is the location that it was dropped into, this flat area that's outside of this kind of complex river delta. And this is Jezero crater here. What the goal is actually to eventually work its way up into these gullies. As this mission unfolds over the next couple of years, to sample various sediments that might have been laid down at different times in Mars's past, until eventually it's hoped some of the very early time on Mars, when there were standing bodies of water, channels and so forth being formed, and perhaps early forms of life can be identified. And the plan then is to send a subsequent mission, probably somewhere around 2026, to bring some of these samples back to Earth for analysis. So this is part of what's planned to be a sample return mission, which will be the first ever done. So here are just some of the details about the geology. Carbonates, of course, are associated with deposition underwater, and this is kind of the route that's going right now. If you have a pencil handy and you're inquisitive about where this rover is at the present time, you can check this NASA site, which is basically giving daily updates of the progress of the rover as it navigates this rather labyrinthine thread through the Jezero crater gully formation. Well, I'm going to end. We've certainly talked about Mars as being perhaps a little bit like Arizona, and it does sometimes evoke that kind of scenery that we're familiar with, probably in Tucson's, more so than Flagstaff. But the reality is, we think that, wow, that looks so much like Arizona, I think I'll just step outside in my shirt sleeves and walk around. The reality is very different. Mars is an extremely inhospitable planet at the present time. Its temperatures are far below zero at night. It goes down to about 200 degrees Fahrenheit below zero. It has an extremely thin atmosphere. In fact, the thickness of the atmosphere is about the same as that on Earth at about 80,000 feet. So far higher than any airplane is able to reach. And essentially, no matter how badly we mess up the Earth, it still will be a more hospitable place for us than Mars. So the billionaires that are hoping to flee the mess that we have here on Earth, at least in my opinion, are basically beating their wings in vain, because Mars will never really be a planet that will likely sustain any kind of Earth life for any length of time. It's just not capable of it. And even if all of the carbon dioxide, which is present on Mars in frozen form, were somehow to be released as air, there isn't apparently enough to warm the planet through greenhouse warming enough to make Mars warm enough so that water can flow on the surface. Well, this is an image. That other one wasn't very good, but Mars can just be seen in the night. Earth can just be seen in Mars's night sky. It's actually not quite as bright in Mars's sky as Venus, mainly a tribute to how highly reflective Venus's cloud deck is. But it can be seen, and through a relatively large telescope, this is what one would see from Mars. This is actually a Curiosity, another one of the rover, which is now defunct, view of the Earth and the Moon. And so I end this presentation about discovering Mars by inviting you to rediscover Earth and to realize that a little bit like with Dorothy and the ruby red slippers, there's no place like home. Thank you.
Thank you so much. We appreciate it. And let me get our camera turned back on here. Oh, okay. 1 second. We'll be right with you there. All right, we will start our video. There we go. We're back. And I'm here at our Central Tucson campus. If anybody here has a question they'd like to ask, you can raise your hand and we'll bring you a microphone. And while I get our, just invite people to put their questions into the chat and we can help bring you on as well. And I'm gonna stop your share, Bill, so we can see you.
All right. Yep, I'll get rid of that.
There we go. And basically, to kick things off while we get questions queued up, I'm curious, in your studies, sort of what are the earliest known representations of Mars with humans? Is it, I know you certainly go back to the Greeks and all that. I'm just kind of curious in your research if there's other things that you've discovered, oral histories or the like of indigenous cultures or the things and what they think about Mars, if you've discovered anything along those lines.
Oh, yeah. There's a great deal about Mars, simply because it was so, it is so magnetic to human attention. But yeah, even the indigenous Australians, going back 40,000 years, have legend about the red man, which was their representation of Mars, someone that was covered in ochre, that basically threw a spear into the sky and grabbed the spear and went up into the sky. So it's part of the dream myths of the dream time of the Australian, and all cultures have legends about Mars, not just the Greco-Roman ones that we tend to think about. And in fact, an Indian philosopher, mathematician, maybe 1,000 years ago, actually worked out way ahead of Kepler's time the elliptical orbits of the planets based on analysis of Mars's motion. So yeah, there's a lot about Mars in mythology. It's one of the with the other planets, one of the things that has impressed people from early times, and been often a source of consternation because of its blood red color. The Babylonians called it the Star of Death, and saw it as an ominous kind of an object that often forecast bad luck, such as famines or war. And yeah, there's definitely a lot of human history around Mars, even before the telescope.
And it's only appropriate we're presenting today after Halloween, where everybody's probably consumed a lot of Mars candy. And
yeah, that's a good name.
So our first question from the audience comes from Robert Bruner. Robert, if you'd like to unmute yourself and ask your question.
Yes, can you hear me?
Yeah.
I'm an amateur astronomer in Denver, Colorado, and I've already been in communication with the speaker.
Right. I recognize you, Robert.
Now, on the Perseverance website, I have my minerals that I have picked that the rover should be looking for astrobiology purposes. And those minerals have to do with the most credible origin of life theories. Now, right now, the Perseverance rover is collecting minerals that are of interest to geology people because they want to know more about the surface of Mars and the geology that formed what you see now. But I'm particularly interested in finding life and looking for places where we might find what's called biosignatures. So to see if you have any ideas of your own about how we can pick the minerals that might be near biosignatures on Mars.
Well, I have to admit, as a Mars historian, that's something that is outside of my realm of expertise, specific expertise about minerals on Mars. In fact, my co-author, Jim Bell, is a member of the Perseverance team. In fact, he's the principal investigator of the camera system. And so he's been continually involved in analyzing the data that's been coming back with a team of collaborators, and they're on Mars time. I mean, one of the things that they have to do is adjust their sleep wake cycle so that they can be able to be present when the data is downloaded from Mars. And so these are people that have been sort of living on Mars time since the mission started back in February. So I don't know what they're finding, but I think the you in fact probably are more able to answer the question that you asked than I am. What are your thoughts, Robert?
Well, I've spent ever since 2014, when I went to my first Origin of Life conference, I've been trying to figure out which of the theories of the origin of life on Earth might apply to Mars. And these are scientists that all have studied this stuff for years. And I have a list of them at the Perseverance website. It's the presentation I gave was October 16th at 11:10 a.m. So if you go to that website, you could see the minerals that I picked. But there's a lot of competition from the geology-oriented people who want to fill the sample tubes with stuff that will help them figure out the geology of Mars. So they haven't really got the astrobiology samples yet.
Right. Yeah. No, I think the fact is that they already, with some of the previous missions like Curiosity and Spirit and Opportunity, they've actually seen the different layers of sediments, because they've found sedimentary rocks in those locations. And so the higher up sediments are obviously the younger ones. And as for instance, in this case, Perseverance continues to traverse the surface, it's going to be going to lower and lower levels, which are older formations of Martian geology. And the hope is that once they encounter some of the rocks from the era when Mars was more congenial in its climate, and when water was able to exist on the surface, they might be able to discover some of the rocks that would be potentially sources of biosignatures. But I think they still have a way to go before some of those prospects emerge in real time.
Also, I want to mention that I cross-checked these origin of life minerals with the minerals that have been found by the orbiter that has the CRISM instrument. That CRISM instrument is run by the Applied Physics Laboratory at Johns Hopkins University. And they've been able to find some of these key minerals in Jezero Crater. So it's not a wild goose chase. These minerals are there. For instance, serpentine is one of those minerals. That's the result of the serpentinization process. Opaline silica is another one that's been written about for many years. There's chert, which is one of the theories of the origin of life has to do with it occurred between the layer in the bottom of the ocean, and it's called silica gel. And when silica gel flows and then it stops, it turns into chert. And chert is so hard that it has to be brought back to Earth to break it up so that they can look for these biosignatures. So some of this stuff that you could do with the rovers, you still couldn't accomplish with the rovers' instruments what you'd need after you bring the mineral back from Mars back to Earth in 2031. it's going to be another 10 years before we have these minerals back on Earth.
Right. I think that's all very interesting. Thank you, Robert. That's great to have heard about.
Kind of related to what Robert was after, what are the objectives of the current mission, the Percy mission right now? What are their primary goals?
Well, I think that the goals are basically to look in detail at what the geology is in this very interesting formation on Mars. I mean, there was an intense competition to decide which site to return to aim at for a sample return mission. Some scientists on the team wanted to go back to some of the sites that had previously been looked at, like Gustav Crater or Gale Crater, just so that they could perhaps follow up on some of the leads there. But this site really emerged as the most intriguing because of the complex sort of interlayering of different geological sediments that seem to suggest the possibility that some of this was deposited in underwater, and that some of the minerals, as Robert was saying, like carbonates and so forth, were associated with that type of deposition. But the goal is to basically survey those areas as the Perseverance rover goes up through the kind of channel there, and it goes deeper and deeper into the layers of Mars, and to find specimens, rock specimens that can be brought back to Earth for analysis. And the importance of doing the in situ analysis is demonstrated by the whole history of Mars having thrown us off the scent, as it were, with one false lead after another, including, we didn't talk about it, but the Viking era, when the landers initially thought that they found robust evidence of biological activity. And later that was, though upheld by some people, it was sort of eventually decided to be inconclusive. So we really need to have, and some of the samples, as Robert was saying about Chert, need to be analyzed in the laboratory, in order to find out about these kinds of interesting questions. And nobody had mentioned this, but we had in 1996 a previous book that I did on Mars for the University of Arizona Press came out shortly before the fossils in a Martian meteorite announcement, when people thought that they saw microscopic evidence of life forms at a level of about size of bacteria, and that ended up eventually also being disputed. So it just we really need to get samples in order to really be able to say for sure what is going up there in terms of biology.
We've got a question here in the room with Clara, if you'd like to ask your question.
This could be kind of a silly question, but you mentioned Mars time. And what is Mars time, and how is it affected by the great distances that Mars moves away from the Earth?
Okay, well, the main reason that Mars time exists different from ours is that Mars, though it has a very similar rotation to that of the Earth, its actual rotation period is 24 hours, 37 minutes. So basically, Mars is continually getting out of sync with Earth rotation. And obviously, that means that the positions on Mars are going to shift from day to day. So every day, if you look at a particular position on Mars, it's going to shift by about, well, it's going to be running 40 minutes behind. And over a period of about 40 days, the planet is going to be one whole rotation out of sync with us. So if you're working on a Mars rover, I mean, the Mars rover is in a specific position on the surface of Mars. It's communicating via orbiter link. And I think with Perseverance, it's the Mars Reconnaissance Orbiter that's doing the relay. And so people have to keep shifting their work time in order to stay in sync with where Mars's various spacecraft are located. So that's essentially what's going on with that. As far as the distance goes, it does create some difficulties in the sense that it's about a half hour, when Mars is closest to get the signal. So it's really not a great difficulty, but it does create some challenges for the people that are having to operate the various, like the lever arms on some of the sample instruments. Because essentially all of that has to be very carefully pre-planned. And so some of the real unsung heroes, and actually in this case also heroines, are perhaps the people that have to figure out in advance how to move the lever arms for some of the sample return instruments on the rover in order to pick up that particular rock or to decide where they're going to go. They can see the image, but that has to be planned in advance because there's no, instantaneous reaction. If you make a wrong move, it's going to take, an hour or more to get the message to Mars and back again to change that sort of thing. So, that's also something that they do a really good job with, but requires meticulous planning. And these people have to be, more perfectionistic in what they're doing than brain surgeons, because if they screw it up, it means that the billions of dollars of investment are lost.
Just as a quick follow-up, why do they have to work on Mars time? Why can't they work on Earth's time?
Well, because what will happen is essentially the position of the spacecraft will be veering out of view. It's kind of like if I want to, let's say that the bus runs that I take every day runs 10 minutes later every day. If I don't shift my schedule in order to catch the bus 10 minutes later, I'm going to miss the bus, right? Or else have to wait for a long time. So it's sort of the same idea that you have to line up with when the spacecraft is in the position so that you can get this data that you need in real time. I think I might have had my analogy backwards, but anyway, you get the gist of it.
Got it. Thank you.
Got one more question from Scott in the room.
Yes. Are you coming through? Oh,
Yeah.
Oh. So I'm an amateur astronomer also, and I'm curious about how far beneath the surface of Mars have they gone with their digging up of rocks?
Well, I don't think they've gone very far. I think it's more, like maybe late on the order of a foot or so, but I'm not absolutely sure of that.
Thank you.
Does anyone else out there know the answer to that question?
Anyone wants to put it in chat? I'm not sure either. We've got Saul Grossman. I'm going to ask you to unmute yourself and we'll see. I know part of your question was, I think, already answered, but if there's more you want to explore with that, go ahead.
Yeah, you did principally answer it at the end, but wondering if you want to elaborate more on the issues of colonization of Mars?
Okay, well, there are people that have distinctly different points of view about this. And there are some people that are optimistic about the ability to do things like terraforming and, to be able to change Mars's environment to make it more benign, able to support life. And then there's certainly people that are thinking of colonization in a much shorter term, where basically, for instance, it's known that there are, that water exists in abundance, below the soil, that there's a lot of carbon dioxide, for instance, in the polar caps. And that some of these raw materials can be used to develop, a suitable habitable conditions to a limited extent. Well, my thinking is that it's a big mountain to climb, simply because Mars is so incredibly inhospitable, and it combines all of the tropical enticements of Antarctica with the pure clear air of the upper stratosphere. I mean, it's just a very inhospitable environment. And I think that one of the problems that we have, and I've always had with Mars, is that we tend to project our wishes and our hopes onto Mars. The other thing is simply that we've become so sophisticated in terms of the kind of robotic adventurers that we've produced, that increasingly it's hard to actually think about what humans would be able to do on Mars that couldn't just as well be done by some of our robots. And you really have to think in terms of what we are as humans. I mean, we evolved. We are a species that was basically designed in order to swing from trees, and we have color vision because we needed to recognize fruit and so on. So, I mean, essentially, when one talks about sending humans into long distance missions into space, essentially it costs a lot in terms of support systems to send computers made of meat into space. So, and the other thing, though, I think is simply that, and this is discussed a lot by the people involved in the search for extraterrestrial intelligence, namely, how many civilizations are there in the universe, and you can map that out in terms of the Goldilocks placement of the planets relative to the star, what kinds of stars are steady enough and that could support a long history of evolution that would lead to potentially to, I don't say intelligent people, species, because I think intelligence is possessed by a lot of species on our planet, but technologically capable species that could communicate with across the galaxy. And there are all sorts of calculations that you can do around those questions. But what it really comes down to is what is the likely lifespan of a technologically sophisticated civilization. And I've talked to Frank Drake about this and other people. And what really comes down to is, we're not showing a real lot of promise at the moment in terms of our own long-term longevity on the planet. And as I showed, the Earth looks like the most beautiful oasis in space. We've seen that image in one way or another since 1968, when Apollo 8 went around the moon and Bill Anders took the Earthrise image. So we've seen how fragile and how vulnerable the Earth is, how lonely it is. And so, I think any kind of a plan to colonize Mars is predicated on the assumption that somehow we can get our act enough together on Earth in order to be able to to do those kinds of things. And so I think colonization is a moot point at the moment, and that the greater challenge and perhaps the harder one is going to be, how do we colonize the Earth to make it survivable?
Well, thank you so much, Bill. And we've hit our time, but thankfully one of our members, Sally, has done her research on the internet for us, and they've drilled 2.8 inches or 7 centimeters, but the rover is designed to dig up to 6.5 feet or 2 meters, it says.
Excellent. Well, we barely scratched the surface on this topic today. So we probably made it about an inch into all that we could have talked about, but the rover is doing better at least.
Well, we've put a link into the chat for those participating remotely to the book, Discovering Mars, with U of A Press. And hopefully those that want to dig deeper will go and look into that. And any final words, sir?
Well, I thank all of you for coming out. And I'm glad to see all the masks in the audience. That's certainly reassuring as a fellow Arizonan. And I wish you happy flights to whatever planet is your next destination.
Well, the thing I always say that's hard about these webinars is you don't get to hear all the thunderous applause and all that, but we do have some of in the room, some of the folks can make some noise, but thank you so much. And thanks to everybody for joining us from around the country and locally. And we'll be back again in 2 weeks for our next speaker series. But thank you, sir. And we appreciate it. And best of luck with your latest book. I'm sure. What are you working on next?
Well, I got another book that I'm working on Venus, actually. And that's with University of Wisconsin scientist Sanjay LeMay, who actually has put forth some fairly compelling arguments that there may exist microorganisms in the clouds of Venus. So, if all else fails, we can always divert our attention inwards towards the sun if we get cold feet about Mars.
Well, thank you again, everybody, for joining us, and we very much appreciate it. And we'll see you again in 2 weeks. Take care.
Thanks, everyone.
Well, to hear that or not, Bill, she's talking about how inhospitable Venus is as well.
Right. The idea, and it hinges sort of on whether or not Venus had oceans early in its history, which is a moot point. Some people say that it probably did and then lost the ocean subsequently, although there's a recent paper in Nature that suggests that maybe Venus never had oceans at all. But the idea is really more has to do with microorganisms that could have adapted to the atmosphere of Venus, and not any suggestion that there's life on the surface, which, as you say, is, unless you have an appetite for drinking molten lead or things like that, it's not necessarily a place that would even attract the average tourist. But in the clouds of Venus, it's quite a bit different. And in fact, I think in the December issue of Astronomy magazine, I have an article that kind of lays that out, the way that life could have evolved. And according to some scientists, I wouldn't say the majority, but some, respectable thinking people in the field, they may explain these ultraviolet absorbers that have long kind of puzzled astronomers because there hasn't really been a totally successful explanation for them. And there's at least one school that suggests that these may be sort of rafts of or colonies of microorganisms that live out their whole life cycles in the clouds without ever getting close to the surface. I have to admit, I'm skeptical to it, but on the other hand, wonders never cease, and it's always fun to work out possible scenarios where this would be possible. But yeah, Venus is another case like Mars where planetary evolution has seemingly taken a wrong turn from the beginning, and so we're sort of lucky on Earth. And even at the present time, there was a really interesting book that I read that showed that even on Earth, what we've been living in since the last ice age, for instance, is kind of a sweet spot in terms of the Earth's climate. And that if you go back, to earlier times, say the Jurassic, or other earlier times in the geologic history, often the Earth has been an extremely inhospitable place as far as all that goes. So we're really sort of confined at present to the fact that we only have one planet that we've been able to study at first hand. And as any statistician will tell you, it's probably not a good idea to put too much stock in research that has an N of 1.
Well, I think we're long out of time, and it sounds like we could easily start a whole nother talk. So I want to
Yeah, I was going to mention, what about Jupiter?
Here, but Mr. Bruner has more comments for you he'd like to share. So I'm going to invite him to contact you again directly. And thank you so much. And we'll see you, I'm sure, for another round, it sounds like.
Well, there's lots of planets up there, and the estimate is perhaps many trillions when you start looking at the universe as a whole. So we'll not run out of topics soon.
All right. Take
All
care
right.
again. Thank you. This is our fourth goodbye, but this is the real one. So thanks again so much, and we'll see you next time. Take
Sounds
care.
good.
Bye-bye.
Thanks so much. Bye.